Alright, so now that we've learned about how simple it is to use these axis rotations, X, Y, and Z, now I want to talk a little bit about the limits of Euler rotations. And we're going to go into a problem called Gimbal Lock, which is the manifestation of this, the endpoint. But we have lots of problems in the middle. So first I'll highlight that these rotations actually work fine if you want to rotate something or orient something. You can achieve desired orientation using these methods. Simply by combining multiple transforms. So any orientation you want, you can figure out how to solve it. I have a phone here, any orientation I want, I can solve it using these three. So that's great. So you can combine them and do something like this. My point, let's say I have RZ, RY, Rx. Now the first thing to highlight is, just like with all of our other transforms, the order here matters. Okay? And let me work through an example. Let's say I have this square and I want to rotate it. So first I'm going to rotate it around my z-axis. Now remember, the z is I turn this way. So it'll turn into a diamond. Good. And then I'm going to rotate it around my x-axis, which is this way. And I turn it until it goes to a thin slice. Now, if I do them in a different order, intuitively, you might think it's the same rotations. But I'm going to rotate in the x first. So I'm going to take this and I'm going to turn it to a thin slice first. And then I'm going to rotate it in the z direction. And I'm going to have an angle like that. So you can see that the order that we do the rotations in matters, and you get a different result. Okay. So because of that, it actually can be quite tricky to use these. It can be quite tricky to use these Euler rotations. And a real problem is it is really hard to do interpolation. So it is hard to smooth between or to interpolate between orientations. For example, if you're animating. So let's say I have these two objects here, right? And I have this in one orientation. I can do the same orientation. But let's say it's over here, and I want to smoothly do that. I want to just smoothly do that and make it match the orientation. How do you do it? Well, it's really hard with Euler transformations. You have to on-transform it and then move it and then calculate, okay, how can what's one step more towards the other orientation, and add that and transform it back. It becomes really, really messy. It's really hard to do, okay? Even without this interpolation problem, the results are unintuitive. Okay? The results don't look as you might expect. And instead of explaining this all, I'm going to work through an example here. Okay. So here's an example. There's a lot of things in here you might not have seen. Don't worry about it. We'll learn them in the animation section. But what's important is I have this draw cube down here, which draws a cube, a unit cube, -1 to 1. And then up here I have some transforms. We resize it up here and we offset them. We have an angle that we're interpolating. Don't worry about this function, but the angle is just slowly going up and coming back and looping. That's all that we're doing with it. So I printed out my angle so you can see it down here, and you can see that it's working. So what we expect to see here is I have this cube, and it's just moving around the scene. Okay, don't worry about that. I'm moving it around the scene, and then the angle, I'm going to rotate X, then Z, and then Y by the same amount. So you might expect, okay, I'm just doing this constant rotation angle, slowly getting bigger. You'd expect this constant rotation. So let's see what this looks like. Okay, so it looks cool, right? Look closely. Let's just watch it. It looks like it speeds up and slows down. Speeds up, slows down, speeds up, slows down. It's kind of weird, right? It's kind of unstable feeling. It doesn't feel like a smooth rotation through space through some orientation. Okay, so it looks weird. And the reason why it's doing that, and I'll come back to that, is because we're applying these in this order, right? So that X depends on Z, which depends on Y. They're not independent. So you get this funny thing where they line up just right and they cancel out, or they line up just right and they double up. So the speed changes. So the other thing I want to talk about is the order of the, I'm going to undo this, the order. So I have 3 identical cubes with 3 X, Y, and Z rotations all being identical, but the difference is the order. The top one is X, then Z, then Y, then Z, then Y, then X, and then X, then Y, then Z. So 3 different orders. And you would expect them intuitively to look kind of the same. But as I showed in my example, they look at this, they look completely different. And that's not intuitive. So they're unpredictable, they're unintuitive, and you get this unstable feel if you're not really, really careful with them. Okay. Let's go back to the iPad. So the results don't look good. Sketch 4. All right. So why is this happening? What's going on here? The first piece of the puzzle is up here. It's this order matters business, and I talked about it briefly in our demo. It's because the rotations are not independent. It's because the rotations compound. Okay? One's lower in the hierarchy. They depend less. Sorry, not less. They depend on one's higher in the hierarchy. So if I change one rotation, it actually impacts how the other one behaves. So let's work through an example of that. I'm going to use RY. Oops. I'm going to use RY, RX, RZP, and I just choose this order to match a video that I have. So you can imagine I have P over here, some shape. The first thing that's happening is Z. I'll make this blue. I have the Z rotation, and this is like, if you imagine you grab the wheel and move it to rotate P sideways, rotate it sideways. This is the Z. Okay. This is my Z axis rotation. And that happens first. So I'm going to start drawing a hierarchy down here. I have P, and then the rotation Z happens first, which is blue. That's fine. What's next is the X, and I'm going to draw that in purple. So the X rotation is, remember, you grab it this way, okay? And it goes like this. So you can imagine it's kind of like, my 3D drawing sucks here. But you can turn the wheel this way, and you can rotate it. Now, the thing is, though, when I turn X this way, the Z underneath it moves as well. So when I rotate X, the Z coordinate system changes. Right? Because Z no longer rotates independently. It's dependent on the axis that X has moved it into. So you move X first. If you apply X, second rather, I guess, you apply Z, but after X is applied, it modifies what Z does. And that's my X. Happens next, and that's purple. And the last thing in the chain to happen is my Y-axis. I grab it and I turn it this way. This is my Y. Now, if I move the Y around, the X-axis moves and the Z-axis moves. So I move the Y, move the X, Z doesn't know where it is anymore. They compound. If I move Y, both X and Z change. Okay, so because they compound, it's really, really confusing. Right? If I change the axis, if I change Z, Y rather, all of them change. So remember from a previous lecture that transforms actually change the coordinate system as a change of basis. Okay, it's a change of base. They actually change the coordinate system. So when I change one, it impacts the coordinate system of the other down the chain, okay, or up the chain, because y is changing the coordinate system that I'm working in. Now, what we saw in the video of them slowing down and speeding up is that when you modify one and you modify another, they kind of line up. They don't impact the final result the same because there's an overlap in their axes. And this can get really bad. In some situations, the axes can even line up perfectly. Okay, so that so they line up perfectly, so that changing one is the same as changing the other. So if these axes line up perfectly, changing two axes have the same effect. So it says this is a situation where I want to move in a third dimension. Wait a second, I have three rotation axes, right? If two of them give the same effect, I'm no longer free to move my object any way that I want. Okay, so if two of my axes I rotate X and Y and they have the same effect, then I can't move it that way or the other way that I wanted. This is a problem that's really confusing. This is a problem called Gimbal Lock, and I'm going to give an example of this. Okay, I'm going to go show a video and an example. So coming back here first, you could imagine that I could rotate X, right? Turn it around to make Z move, and if you do it just right, you can make Z line up. You can make Z line up with Y. Right? And fold Z down. Z and Y are lined up. Now if I rotate Z and Y, I get the same effect. So let's watch a quick video on this, and I'm also going to have a working demo.
Hierarchy, or the last axis in the...
I started playing, of course it did. Alright.
Z, on the other hand, affects the arrow, because it's at the bottom of the hierarchy, or the last axis in the rotation.
So these are three axes, just like in my picture, except better drawn. And you can see when I move the blue one, the arrow moves as expected.
Rotation order. X is second in the rotation order, so it'll affect Z below. And see how Y stays still, because it's at the top of the hierarchy.
System changes? That's a visualization of how you're actually modifying the coordinate system lower in the hierarchy.
Now here's where things start to get interesting. If we continue to rotate X in the middle of the hierarchy, it'll cause Y and Z to align.
Right there, look at that. So if I rotate around the blue one, the arrow moves this way. If I rotate around the green one, the arrow goes this way. And you're like, wait a second, that's weird. Why can't I just grab it this way and rotate it? Because you've changed the coordinate system with the other transform. You don't have that coordinate system anymore. When blue is working, its X is this way and you can rotate it. And when Y is working, its Y is this way. You line them up. That is called Gimbal Lock.
Here, this rotation order hits Gimbal Lock when two axes align.
See that?
If we're animating...
So that's the problem. Let's see if I can bring up an example, sketch 5. Here we go. So what I've done here is I have another example. I have a cube that I can rotate with some keyboard keys, and at the bottom the angle X, angle Y angles that'll come out. So I have the same unit cube. It's a bit bigger this time, and let's look at the main function. We don't have that anymore. Oops, maybe I can leave it on. But I can rotate my X, my Y, and my Z by using the keys in my keyboard. So let's just take a look at this. So as you might expect, I'm going to rotate with my X-axis. I grab it and I turn it. Right, it works as expected. I'm going to rotate my y-axis. Works as expected. I'm going to rotate my z-axis. Works as expected. Now, if I look at my rotation angles, x, y, and z, I can, as I said, I can change my y to bring z, line it right up with x. So I'm going to change my y to be, where's my y? Wrong way. Y to be 45 degrees, pi over 2. Down here, y is 4 or 5 degrees. X and z are basically 0. 90 degrees, actually. There we go. So 90 degrees. Cool. Now I'm going to rotate z. Wait a second. Isn't z supposed to go this way? Well, no, because z is below y in the hierarchy. Look at my z changing down here. When I change the z, because you've rotated the coordinate system, it's actually changing it this way. I'm going to change the x. Hey, it's the same thing. Look at that. I'm getting this is my x getting bigger. It's the same thing. Y is getting, Z is getting bigger. It's the same thing. And it's not until I move Y out that we break the gimbal lock, and you see that they become different again. Really weird, really confusing. But because they're hierarchical, you're changing the coordinate system, and you're not maintaining that global rotation anymore. They compound. Okay. So, yeah, that's not cool. That's our gimbal lock. I'm gonna write in the video so you can Google it. Euler gimbal lock, and I showed you at about 150. And we also did sketch 5. So Euler angles work. You can orient things any way you want, but you have these weird problems with animation. You have these weird problems with gimbal lock. So we need a new approach. Okay, right. So I went over the problems with Euler rotations, but yeah, we need something better.